Good afternoon, guys. So, welcome to the session of domain analytics, which is sponsored by 360DigiTMG. Okay. So, as we know, we were seeing the session of linear regression. Okay. So, we are seeing about linear regression and how it will be useful in automative analytics. Okay, so in yesterday's session, if you remember, we have gone through our agenda. So we have seen what is the importance, what is meant by linear regression, what are the types of linear regression, and why we are going to use this linear regression. Okay, so moving on, we'll be seeing today. So how this linear regression has implemented. Okay, how this linear regression has been implemented in this things. So guys, in yesterday's session, we have seen the linear regression was, okay, like how we're gonna predict the price. So if you ask me, so in the last session, you can see, we have seen predicting used card price, okay, predicting used card price. Okay, so and we have seen all the, so let me give a quick recap. So what we have done, let's go on a quick journey. So guys, here what is the prediction? The prediction is based on the price of the car used, okay, in India. So data set, what the data set consists of? Data sets consist of serial number, name of the car, which includes brand and model name, manufacturing year of the year, fuel type, owner type, and we have seen what is the mileage we are going to get, okay, and we have seen transmission, the owner type, the engine, the power, new price, and much more things. So these things we have been recapped on the yesterday's session. So we have seen the data set. So what all it consists of, okay, and moving on further thing, we'll be seeing what is the problem we are facing in linear regression. So guys, due to various predicting factors affect on the price, okay, the what is the price on this used car, what all independent variables, okay, is affecting on the used cars. Does name of car have any effect on pricing of a car? And we'll be seeing how does type of transmission is gonna work, okay, and we'll be seeing how location in which, okay, in which car is being sold on what effective price, okay, and does the mileage, the engine, okay, how does number of seat, fuel type affect this pricing, and the libraries. So if you see the libraries, so we have used different type of libraries. So we have imported the libraries, okay, so we have imported libraries like stats, pandas, numpy, matplotlib, seaborn, okay. So we have seen what type of libraries we have imported and why it is important, okay. So guys, the numpy, the pandas for data manipulation, numpy for numerical calculator, okay, we know in the yesterday session we have seen why these libraries are important and what is the role of this. So to load the data, we'll be using this, okay, and after importing the libraries, so after importing the libraries, we are going to understand our data. So guys, you can see I have got my bottom rows, okay. So we have different brand companies, Maruti, okay, we have like Honda, Ertiga, Audi, okay, and we have the number of observations, count on unique values. So after getting the size of the data frame, the rows and columns, the location, what we have, okay, the price, what is my new price, what is my low price, okay, And after getting all the values, we are gonna see the info. Okay. So to write the code, we have written cars.info, so which is gonna give me the information. Okay, it's gonna give me the information to the data frame. So after that, I'm gonna visualize the missing values. So I have visualized my missing values. You can see name, location, year, driven, fuel type, owner type, okay, the price. And after that, you can see the observations. Okay. So the new price has only 1006 values. And the mileage, the power engine has 46 missing values. So what I have done here, I have done printing. I'm gonna count unique value in each column. So I'm gonna count the unique value on each column, and I'm gonna see the observation. Okay. So guys, after that you can see I have done data pre-processing. Okay. So after doing data pre-processing, processing engine, mileage column. So these things I have done. Okay. So you can see. Okay. So after doing data pre-processing, you can see the power as some null BHP and CNG LPG is in kilometer. So since those units are both of them, we need some of conversion, guys. Okay, we're going to drop mileage, engine, and power. After that, you can see we have dropped mileage, engine, power values. Okay. So after verifying the data for engine, for mileage and power, we'll check once again after converting our data type. And after converting the cars.log, okay, we are gonna see the engine and power, the mileage thing, and we are gonna see what is the missing values we have. Okay, so what missing values we have, and we are gonna import some libraries. We're gonna calculate the new price, add new column to the data, checking now the data frame. Okay, so I'm gonna type cars.head. Give me the first 5 values. So okay. So after converting the data type, we're gonna see, we're gonna process years to derive age of a car. So in year 2014 and 1996, but this data will help us to understand the effect on price, guys. Okay, current year would be 2021. The age column, the age of the car depends on what type of columns we are going to use. So processing the name column. So brands do play an important role in selection on the prices. So extracting brand names from the name, okay, dropping rows with name as null. So as mentioned, the data set car, the brand will find the missing values of price as a brand. Okay. So cars.brand.unique. Okay. So we'll be taking that and we'll be converting the brands like Izu and other things to the correct form. Okay, like Land Rover, something Mini Cooper. You can see here changing brand names. So we're gonna give the exact name. So after that, we are gonna go with unique brands. Okay, so cars.group by. You can see the models, what you have, the size. Okay, So after that, there are 726 unique models, and Swift Desire is most popular model. Okay, so observation. So years is left skewed, and years range from 1996 to 2019. The age of the cars would be 20 years. Okay. So after that, we'll be seeing the price. The engine is right skewed, or the power is priced. So these things we'll be seeing, and we'll be seeing the mileage is almost uh, normal distributed. Okay. And we're gonna price 160 lakh for the car. Okay, which seems to be an outlier. So you can see the plot. So here the year is left skewed, kilometer is right skewed. Okay, we can see the size, the subplot we have got the transaction, the transmission, the owner time. Okay, so after getting, we're gonna see the observation, manual transmission, first owned cars. Okay, and we can see which state has by the most car. So where Mumbai has the highest sales of car, and Ahmedabad has the least. Okay, and 71 71% car has been sold. Okay, so we are gonna see the price versus mileage, price versus engine, the seats. Okay, so we'll be handling the missing values. To see, we have some any missing values. We'll be seeing the location, the kilometers driven, the transmission, the owner type, okay, the age of car, brand. So we'll be seeing this. So guys, after that, we are gonna calculate missing values in each row. Counting the number of missing values per row, we can see the car.isnull.sum. We're gonna see the missing value for the count. We're going to investigate how any missing values per row for each variable is gonna print. So we're gonna see what is gonna happen in the missing values. Okay, so how this missing value is gonna work. And after printing the missing values, we can see there is no missing values found in these exact things. Okay, so this confirms that certain columns tend to be missing together. Okay, so we'll try to fill missing values as much as possible. Okay, so you can see we can start filling missing values by grouping names and year. We're gonna fill the missing values at median. Okay, we're gonna see the cars group by. Okay, we can see the ambassador things. So like the what are the car is available of. Okay, so we'll be seeing the important questions like the things which is important. Okay, the engine, the car's engine, the brand, the model. So we have got this. Okay, and we'll be seeing most of the model which have same engine size. Instead of just applying median grouping with model, more granularity and near to the accurate engine values. Okay, here we'll be choosing median to fill the missing values as there are many outliers. Okay, So what we are going to do, we are going to group by model and here to get more granularity and more accurate engine and then filling the media. Okay. So I'm going to use cars engine, group by brand model name, the engine things. Okay. So that we'll be seeing, which is, okay. So we're after filling them with that things, we'll be seeing. Okay. Choosing median to fill the missing value. So choosing median to fill the missing values. How many outliers are there? Grouping the model to more granularity and more accurate engine. Okay. So I'm going to choose the median, the filling values, the missing values as many outliers. Okay. Grouping by model to get more granularity and more accurate engine. So we're going to see the brand, the mileage. Okay. We're going to fill the things and so still we can see there are some missing values. Analyzing further, we're going to group by only model for engine and then we're going to fill missing values for median, for power, mileage, engine values, for brand, and how can we get more accurate values. So we are going to do mean, median, max for model year engine and aggregate function. Okay. So we are going to see the name which should be given to the granularity and near to accurate the seat values. We're going to see the accurate functions, okay, the how many seats. And last, we're going to check which car type have missing values. Okay. And you can see okay, so we're going to analyze the price if seats are in any role price. And we're going to process the new price, say, for grouping. We're going to see how would be same. The model car is present, so filling the, we're going to see median value and we're going to bring it to near to real value. Okay. And we're going to see, we're going to make some changes in the brand model. We're going to do some data pre-processing. And we are going to see if we have any isn't dots. Dropping rows. So dropping rows to them. We're going to drop the isn't dots. Okay. So I'm going to get the car dots. You can see the important. Okay. And we're going to see the transmission. Okay. And we're going to see the shape. So after doing all this, applying this method, we can see we are finally done with adding missing values. Okay. And we're gonna see the knowledge to create class. So which is the low end model and the high end model what we have. Okay, so we are gonna go with the brand class. We're gonna see bivariate and multivariate analysis. Okay, we're gonna see bivariate and multivariate analysis. And we're gonna see size. Okay. And we are gonna see the observation to correlation. Okay, the price has positive to engine. Okay, and we're gonna see if the mileage is negative correlated and how much kilometer does not impact on price. And mileage, and we can see the plot what we have got. Okay, so after getting the plot, and we can see the plot what we have regarding this, the correlation. Okay, the age of the car what we have, and after that you can see the observation. Okay, so the observation, same observation about correlation as seen in the heat map. So this is our heat map, and you can see the correlation. Okay, I'm gonna kilometer driven, okay, it's not does not gonna have any impact on the price. And car with recent win. Okay, and we'll be seeing engine and power in. So we are gonna see variables that are correlated with price variable. So price versus engine versus transmission. So we are gonna understand the relationship of engine, the price and transmission. Okay, we are gonna see price versus engine based on transmission. Okay, and we'll be seeing price versus power versus transmission. So here we are gonna understand the relationship between price and power. Okay, so price versus power based on transmission will be seeing, and price versus mileage versus transmission. We are gonna understand the relationship. Okay, between mileage and we are gonna understand the relationship between mileage and the price. So after that, we are gonna see the difference between price versus year versus transmission. So price based on manufacturing year of model. Okay, and you can see the price versus fuel type. The next thing we're going to see is price versus fuel type. And price versus fuel type, you can see how it's going to impact on year's price. Huh? Okay. You can see the price versus fuel type, the plot, and you can see year versus price versus owner type. Now we need to check the reason for spike in price of third owner model in 2010. Here you can see the model 2015 was not hike in price. So, but you can see why we need to check now. So what is the price of third owner and how it is increasing model 2019. So the observation for Porsche, the panoramic is expensive and the luxury car as the data is well. Okay, I'm gonna see price versus mileage, the fuel type. Okay, and after that we'll be seeing price versus mileage. So what is the mileage and what is the price it's gonna cost? Okay, so you can see the seats, the price of seats. Okay, and you'll be having what type of data which is important. Okay, and we'll be seeing the location. So where this car has been sold, the location of things we'll be seeing. Okay, the Bangalore, the Chennai, the what type of location. Okay, we have, and next thing we'll be seeing is price versus brand. Okay, price versus brand. So we can see the price and the brand, the box plot you can see, so which is like a whisker plot. You can see the brand, what value we are getting. So after that we are gonna see transmission of automatic manual. We are gonna see the owner type, the one owner type with fourth and above, and you can see the second owner type and the third owner type. Okay. And you can see the of automatic transmission of automatic and transmission of manual. Okay. So the insights based on EDA, the expensive cars in Coimbatore and Bangalore, two-seater cars which are more expensive, diesel fuel type cars which are more expensive than other fuel type, as expected older model and sold cheaper model, vehicles with more engine capacities, price decreases as the number of owner decreases, automatic transmission require higher engine and power, prices for cars with fuel type, engine, how this mileage, the fuel type, location, transmission, how it's gonna affect the price. Okay, so insights based on EDA, we have got this. And now we'll be checking the distribution. Okay, if it is skewed, if distribution is skewed, what is the advice? Okay, so how to transform. And next we'll be seeing the data. Okay, so how this distribution are right skewed. Okay, so we'll be seeing we're going to log into transformation and help in normalization. We're going to perform. So guys, this needs to be done before we are going to split the things. Okay. So after that, we are going to see the data.index. Okay. We're going to do model.building. And we are going to use the things. Okay. So we'll be seeing the model building. We are going to see how it is going to work with this dummy variable, the categories which are covered. Okay. And after that, dummy variable, you can see the before splitting, which categories are covered. Okay. The dummy variable, okay, encode, okay. And you're gonna see the things, okay, like one not variable, okay. And after that, you're gonna see the train and test dot shape, okay. And you can see the stat model, okay, the stat model which has been increased. And you can see how we are going to fit the stat model, and you can see the errors, okay, the model which is in underfitting. Okay, before we move on to any assumption. So guys, this statistical interference from our model, we'll have to test the linear regression assumptions which are followed. The model is not an underfitting or overfitting a model. So before we move on assumption of testing, we'll do a quick performance on checking the test data. Okay, we're gonna standardize the errors, assume the covariance matrix, the errors which is correctly specified. Both the R squared and adjusted R squared of our model are very high. We're gonna get a clear indication that we have been able to create a very good model that is able to explain variance in price for up to 89%. Okay, so these things we have seen and we'll be seeing. So before a quick performance of the test data, we're gonna import the library math. Okay, we're gonna import the library math, and you can see the in sample prediction. Okay, and I'm gonna see the prediction on the data set. Okay, so after prediction on the data set, you're gonna see train.test data, the data which is covered. Okay, and you can see I'm going to use root mean squared error, and much more. So the data frame, the data frame which I'm going to use for this data, you can see. So these things, which is important. Okay, you can see the model performance, which is high overfitting. Okay, so root mean square error of train and test data, which is not different. we are going to indicate is that not overfitting our trained data. Okay, we'll be seeing mean absolute error, and it's going to indicate our current data. Okay, the MAPE, the RMSC. So what is on the test data? So what is mean squared error? What is this? It's going to do. Okay, so mean absolute percentage error, the 23% of our data. So these things can expect, and we're going to do the test assumptions. Okay, checking the linear regression assumptions. No multilinear coarity. Okay, normally you're gonna see the assumption of no collinearity. Okay, and we are gonna use the VF, means the multicollinearity of the data. We are gonna check the assumption. Okay, we are gonna check the assumptions. We are gonna see the data which has been. Okay, and you can see the assumptions. And after checking the multicollinearity, you can see the stats mode. Okay, checking the train data. Okay, checking what it's gonna fit. Okay, and you can see for each feature what we are gonna work. And now we'll remove the multicollinearity. We are going to remove the multicollinearity from the model. We are going to see what is my fuel type, what is important feature in model prediction. So what we will remove. Okay. So what is the model performance? And we are going to see the regression results. Okay. We'll be seeing the OLS, ordinal least square. So we're going to see which is the data which is important. The number of observation, the residuals, the method, the time. Okay. And we'll be seeing about covariance data type. Okay. So after that, we are going to see the kilometers. Okay. The kilometers what we have. Okay. So which is a driven long location in Coimbatore, Hyderabad. Okay. And we'll be seeing the cost, the standard errors, the same thing of the covariance matrix of the errors. We'll be seeing the condition number. Okay. We'll be seeing the other numerical problems. And you can see the other numerical problems what we have. And we'll be checking the VFX train. Okay. And now we have removed multiple linearity. Okay. So from type of variables, we'll be seeing those two features which are correlated to each other. Okay, now we'll not drop variable from the model, and we're not going to affect the interpretation. Okay, so guys, we are going to see So now we'll be removing the petty collinearity data. Okay. So we'll be seeing it is either diesel or petrol. Will not drop this variable if this interruption of the future in the model. Okay. So we'll be seeing there is no heteroscedasticity. Okay. And we'll be seeing if this homoscedasticity and hetero, if we have residuals which are symmetrically distributed across the regression. Okay, if the these residuals are symmetrical, it is said to be heteroscedastic. Okay, and you can see. Okay, so after that, we are gonna see if this homo or hetero, if both are residuals or not. Okay, so we'll be seeing. So we'll be seeing how we are gonna import stats.model. Okay, we'll be seeing SMS and we'll be seeing the stats model which we are gonna import. Okay. And we are gonna check the assumption of linear variables. Okay. We are gonna check the assumption of linear variables. So after checking the assumption of linear variables, okay, we are gonna predict the must have linear relations. We are gonna see the dependent variable, the assumption, okay, the strong pattern. They should have randomly scattered on the x-axis. We are going to use the predicted values. Okay, we're going to get the predicted values and we will be seeing what is the important mistake. Okay, so we'll be seeing the residual plot. Okay, we'll be seeing the residual plot and we'll be seeing the data. Okay. Okay, and we're going to check the assumptions, okay, which is in normally in the form of error terms, and we'll be seeing the plot which we are going to plot for different data types. So the data types what we have, and we'll be seeing the data. Okay, so we'll be seeing the data, which is important, and after the collinearity of this normality of terms of errors, we'll be checking the assumption. Okay, so after checking our assumptions, so checking our assumption, you can see what type of normal terms of errors we have. Okay. The residuals are normal distributed. We are going to use QQ plot for residuals. We are going to import. Okay, we are going to import the SkyPy and the stats what we have, and we'll be using the plot. Okay, so after plotting, you can see the probability plot what we have got. Okay, we're going to use QQ plot for the residuals. So the residuals which have those two normal distribution, the assumption phi is also satisfied. We should have further investigate these values in the tails where we have made huge residual errors. So guys, now that we have OLS model 2 is going to follow the linear regression assumptions. Okay, so let us see this model which is going to draw an interference. Okay, so I'm going to print the model by checking the model performance. So after checking the model performance, we'll be seeing the OLS regression results. So what results we have got applying the linear regression? So OLS is nothing but ordinary least square. Okay, so OLS is nothing but ordinary least square. Okay, so after getting ordinary least square, you can see the standard errors. Okay, we are going to assume the covariance matrix of the errors, which is correctly specified. The condition of the number which is large, which might indicate that there are strong multi-collinearity of numerical problems. The root mean squared error, the mean squared error, Okay, so these things will be applying. And after that, we are gonna observe from the model. So what observation I'm gonna get from the model? So it is important to note here that the predicted values which are in the log price, therefore the coefficients have converted according to understand their influence in price. So basically, without our linear regression, the model we have been is able to capture the 89 variation of our data. Okay, the model indicates the most significant predictions of used cars are age of the car, power of the engine, mileage, okay, fuel type, location, owner type. Okay, so we have got all the information, okay, which is required to get the observation from the model. Okay, we have got observation from the model. So after getting observation from the model, we can see the age of the car, the power of the mileage, okay, and you can see the owner type, okay, and you can see the transmission, okay, and you can see the automatic, which is it is that automatic or manual, okay, and you can see the fuel type, the owner type. And you're gonna see how the unit is gonna increase. Okay, how this unit gonna is increase in the age of the car. Okay, when everything else is constant. As the number of the seat increases in the price of the car. Okay. Okay. So as the number of the seat increases, the price of the car decreases. Okay. So after that, we'll be seeing the mileage, which is inversely correlated. Okay, the mileage, which is inversely correlated. And we are going to see the mileage. Okay, the low budget cars. Okay, the kilometers which have negative relationship, the price of the initiative, a car that has been driven more. Okay, will we have what type of data? The categorical variables, which are little hard to interrupt, but it can see all of the car category and variables in dataset having a negative relationship with the price. Okay, so the negative relationship, which is going to decrease in the brand category of the lower brands. Okay, and we'll be seeing the recommendations. Okay, we'll be seeing the recommendations. Okay, and after that, recommend the categorical variables. You can see the data. Okay, so what type of variable is used to interrupt? Okay, so what type of data is used to interpret? So which type of data we can use? Okay, so I'm gonna see the magnitude of negative relationship. It's gonna decrease. Okay, it's gonna decrease as well. Okay, the lower brands. Okay, and we are gonna see the price with the magnitude, the brand which has lower thing. Okay, and we're gonna see which is the category. Okay, so what type of category which has a lower brands. Okay, and you can see the data points what we have, and the hence this all things are important. You can see, okay, you can see the data. Okay, so the data which is important. Okay, so data which is important, and you can see the data point. Okay, now the recommendation thing. Okay, and you can see the data which is very valid. Okay, and you can see, okay, so the recommendation you're gonna see is important. Okay, so after that we'll be seeing the data, the relationship will be seen. Okay. and we will be seeing the kilometers which have been driven. Okay, the data which has been driven, and we'll be seeing the negative relationship. Okay, and uh, we'll be seeing the recommendations of our linear thing. Okay, and we'll be seeing the data. Okay, we'll be seeing the data which is important and the thing, and we'll be seeing the recommendation. So what is the recommendations we are going to get at the last? So guys, the recommendations, our linear regression model has made. Okay, our linear regression model has made, and MAPE has 23% on the test data, which means that we are able to predict within 23% of the price value. Okay, so this is a very good model, but can be further improved. So for the justification, the recommendation, if you ask me, the MAPE has been calculated 23%, and it can be further improved. Okay, some solutions, some southern markets tend to have higher prices. It might not be a good strategy. Okay, without having cities information, without having the markets like Kolkata, we don't have investments in the area. Okay, we'll be having this based on analysis. We can decide. Okay, like Hyundai, Honda, the used market, brand market like Toyota. Okay, Volvo, and what are the medium budget cars. Okay, Mumbai and Hyderabad, what type of data we have. Okay, so after that we'll be seeing the data. Okay. So we'll be seeing the brands like Volvo and everything. We'll be seeing like that, and you will be seeing. Okay, so after that we'll be having the value of the brands like Maruti. Okay, and we'll be having the recommendations like brand like BMW, Bentley, Jaguar. Uh, these are the most bought cars by the ready to use guy to users. Okay, so Mumbai and Hyderabad seems to be more popular in used market. So when we done the this regression, guys, we have seen which city has more thing, right? Hyderabad, Mumbai has more, and the least was Ahmedabad. So the next step is that we are going to see the cluster different set. Okay, we need to acquire the different multiple models in different locations. Okay, we're going to earn more profits as the car is going to set on higher prices. With increasing petrol rates, diesel car and more in demand, we are going to acquire the selling price. Okay, so along this, we are going to include scheme like a test drive. Okay, pursue customer to buy. We can provide car maintenance packages. Okay, where customer pays a small upfront buying the car of serving anytime. Okay, so the important points which is in this linear regression we implied is that there are more soft parameters which should be considered when buying a car. If the car is has already in some kind, okay, other good to have like the impact on the price. Okay. Car model that are too old will deprecate and a lot can impact it. Okay, so guys, we have seen this as it is very important thing. So what can be done? Okay, so the data which we have seen. Okay, so the next thing we'll be seeing. Okay, and you can see the data what we have. Okay, and will be this is the end of linear regression. So guys, you can see the linear regression what we have given. Okay, what we have ended with. So the data what we have got is this many types. Okay, and next thing we have seen the car model which is independent. So guys, applying linear regression. Okay, applying this linear regression, we have seen what is the important? So we have predicted the price. Okay. So which type of car is important, which type of car is gonna improve a lot, which type of car is gonna get more of the data. Okay. So the linear regression, the overall, we have predicted the price of the car. Okay. We have predicted the price of the car. And we have seen how this linear regression is gonna be helpful in the automative analytics. Okay, how this linear regression is gonna be helpful in the automative analytics. Okay, and we'll be seeing the data point, which is important. Okay, and the linear regression, how it is important. Okay. And you can see using this linear regression. Okay, so this linear regression model. Okay, you can see the probability plot what we have got. Okay, so you can see the thing, the what we have got. Okay, and the data point what we have got. Okay, so you can see the linear regression, how it was important in automative analytics. So you can see the errors what we have calculated, and we have seen the data point. Okay, so how it was important with others. Okay, and you can see the linear regression, how it's indicate the price of a car. Okay, and we'll be seeing. Okay, the transmission is automatic manual. Okay, so newer cars, okay, which is gonna increase unit increases. Okay, as a number of seat increases, the number of the car is going to decrease the number of the vehicle. Okay, and we can see the mileage of the car. Okay, so the kilometer which was driven, okay, which have a negative relationship with the price which is initiating, and a car that has been driven. Okay, the overweight, the tier, the everything is being 0. So we have seen the recommendation. So this was the code of the linear regression for automative analytics, guys. So if you want to see the conclusion, so let me show you the conclusion. So the conclusion, so guys, we'll be getting, okay. So I'll be showing the conclusion of this linear regression. So just a sec for that. So let me show you that. So guys, I hope now you can see my screen. Okay. So I'm going to show you the linear regression conclusion. Okay. So what this linear regression is going to do in automotive analytics and automotive industry. Okay, it's keep a tracks of the sales of our variety personal motor vehicles, and we'll be seeing which is going to effort to able, which is going to identify underperforming models. Okay, which you want to use it by relation establish. Okay, we can see the vehicle things and vehicle characteristics. Okay, we'll be seeing the linear by using this linear regression. We'll be seeing the models. Okay, and we'll be seeing the price of the vehicles. So for example, we're going to predict the life of vehicles, okay, by analyzing the parameters, okay, the engine condition, serving of vehicle, okay, the engine size, okay, and we'll be seeing, okay, and we'll be seeing the example, so how it is going to work. So after that, we'll be seeing what is the conclusion, what we have got. Okay, the conclusion. Okay, the conclusion. So using this linear regression, guys, which has been found useful in regression, okay, and prediction, the model is gonna, in fact, it's gonna tell the accurate prediction. Okay, it can handle all the continuous variables, the execution. Okay. the execution of linear, the regression which cannot happen with correct dependent and independent variables. Okay, and we'll be seeing the data. Okay, and you can see the conclusion what we have got. Okay, so using linear regression, we have got a conclusion. It can handle only continuous variable. Okay, the execution of linear regression. Okay, the execution of linear regression is cannot happen. Okay, with current dependent variables. And after that, we'll be seeing how this data will be useful. Okay, so we have seen this automative analytics. Okay, and we have seen the automative analytics, which is important. Okay, so now moving on to the next topic, guys. So we have seen the data type. Okay, so yeah, we have seen different type of data types, and we have seen how this linear regression was helpful in automative analytics. Okay, so how this data was available automative analytics. So this was the conclusion of all the things, guys. Okay, for the linear regression. So linear regression, we have seen how it's gonna import the things. Okay, so if you see the code, you can see the linear regression, the conclusion what we have got, the ordinary least square. Okay, we're gonna check the assumptions. Okay, and we're gonna train our data, test our data. We're gonna create dummy variable before splitting the data and the different regions which we have covered. Okay, the model building and the perform the transform. How can it help in normalization? Okay, and we'll be seeing the insights which is based on EDA. Okay, two-seater car which is expensive. Okay, the older the model, the price of the cars. Okay, so these things are important, guys. So we can see this linear regression, which was having different type of things. Okay, just having different type of things. You can see the vehicles which has engine capacity. Okay, price decreases as a number of this decreases. Okay, the engine power, the type of location, the fuel type of price. Okay, so this linear regression has addressed how it's gonna work. Okay, so and you can see the data point. Okay, so after that we will be seeing what is gonna useful in this automative analytics. Okay, so now remaining thing we see what is an important useful aspects. Okay, so we have seen how this data has been worked and how it is useful in automative analytics. So insights based on EDA we have seen. Okay, so the transition, the overall type, the owner type, what we have, owner type fourth and above. Okay, owner type second, how many cars has been sold, owner type third person, so how many furthermore the cars has been sold. Okay, this transmission automatic or manual, the price versus band and price versus location. Okay, so here we are going to see the observation of expensive car which has which of the data is valid. Okay, and we're going to see cars dot describe. Now we are going to check the reason for spike in price for third owner of model in 2010. Okay, we are going to see the model type. We are going to fix the fuel type what we have. Okay, and we'll be seeing okay, so we are going to see the price versus transmission. Okay, so after that, if the transmission is automatic or manual, and we'll be seeing the price versus the transmission thing. And guys, so here when we got price versus engine versus transmission, so here what is the observation we have seen? We have seen the observation, the which we have seen the heat map. Okay, the kilometer which doesn't have impact on price. As power increases, car with recent high prices. Okay, we have seen the price with the price with less, which is going to increase. Okay, and we are going to see the heat map what we have got. Okay. And now, okay. So now you can see the heat map what we have got. Okay. So you can see the observation, the engine, okay, which has strong positive correlation, and the price which have negative correlation in age of car, and the kilometer is not gonna impact on anything. Okay. As we are gonna get bivariate and multivariate analysis, guys. Okay. So after getting bivariate and multivariate analysis, you can see the cars and the arrays what we have changed. Okay. The knowledge about to create a class, how this linear regression is going to be useful. So where all the data types we have null values, where all data we have nothing values, okay, like zero values, okay. And we'll be seeing, okay, we'll be seeing. So finally, when we are done with this, you can see the data, okay, which we have got is non-dot-sum. Okay, so after that, we are gonna get power engine, the mileage engine. Okay, so after that, okay, after that, we are gonna see the data which is important. Okay, and we have seen the null values what we have car is all not sum. Okay, and we are gonna see the data. Okay, so after processing the new price in linear regression, okay, you can see the price of the median value, which is gonna bring us the real value. Okay, so this is how this linear regression has been used in automative analytics. Okay. So here we no need to analyze the price. Okay, we no need to analyze any role in price, and we're gonna use it. Okay, so when we are gonna use it to the linear regression, it's gonna give us the OLS value, the ordinary least square. And you can see what we have checked in type of missing values. Okay, we're gonna group with model, which is gonna give us more granularity. Okay, and after getting more granularity, and we are gonna get the accurate and seed values. So guys, here the linear regression is done, and we have applied the automative analytics, and we have seen how it was useful for us. Okay, so here we know we still have some missing values. We are gonna group by model for engine, and we're gonna fill the missing values median for power and mileage in engine. We're gonna use the band which gonna give us more accurate value. Okay, and we have chosen the median with filling miss values. We're gonna see what outliers we have. We're gonna choose median with missing values, the grouping with more data. Okay, and so these things we have imported the libraries. So these things we have seen the heat map. Okay, so this was all about the linear regression in automotive analytics. Okay, and we have got the final step too. So you can see the ordinary least square. Okay, and the recommendations and the assumptions. Okay, so and uh, what are the recommendations? What is observation from the model? What are okay? So this was about linear regression. Okay, so this was about linear regression. This was about linear regression in automotive. Okay, automotive analytics. Okay, so that's how we are gonna implement linear regression, guys. And moving on. So next topic. Okay, so next topic we'll be seeing just an automotive analytics, guys. So in tomorrow session we'll be seeing the MLP thing. Okay, so before going to that, I'll like just explain you about what is meant by MLP. Okay, what is meant by MLP? What is meant by multiple linear regression? Okay, multiple layer perceptron. Okay, so you can see multiple layer perceptrons. Okay. The name terminology says multiple layer perceptron. So guys, a multiple layer perceptron is a fully connected element. Okay, it's a class of feed forward artificial neural network. Okay, a class of feed forward artificial neural network. Okay. So it's a feed forward artificial neural network. And you can see the term NLP is used more often because sometimes we are going to use it to mean of it. Sometimes it's to refer to the networks composed on multiple layers. Okay. What is this multiple layer perception? Okay. As we know, it is a feed forward artificial neural network. Okay. It's going to generate a set of output, a set of inputs. And NLP is categorized. Okay. And you can see the NLP uses back propagation for training of the data. Yes, this MLP uses back propagation. Back propagation for training the network. Okay, so this is the important thing of MLP. So MLP is going to use back propagation technique. So what is this perceptron in multiple layer perceptron? So the perceptron is a neural network with only one neuron. Okay, perceptron is a neural network with only one neuron and can only understand linear relationship between the input and the output data, okay, which is provided. However, with multiple layer perceptron is gonna expand this neural network, which can have many layers of neurons, and it is ready to learn more complex patterns. Okay, so this is the important concept of multiple layer perceptron. So, what is perceptron in multiple layer? Okay, so perceptron is a neural network with only one neuron and can only understand the relationship between the input and the output provided. Okay. However, with the multiple layer, the perceptron, which are expanded the neural networks. We have many layers in the neurons, and it ready to learn the complex of neuron structures. Okay, and you can see the data which has been got from perceptron. We are gonna use it for the multiple layer perceptron. Okay, and you can see how many layers are in multiple layer perceptron. So multiple layer perceptron is a supplement of feed forward neural network. Okay, it consists of three types of layers: the input layer, output layer, and the hidden. Okay, this perceptron has feed forward neural network as it consists of three types. Okay, one is input layer, output layer, and hidden layer. Okay, so how this MLP is gonna work? So we'll be seeing guys. So let me explain you about the agenda, and in tomorrow's session we'll be going with the agenda. So we can see the agenda. We have the introduction. We have what is meant by multiple layer perceptron, the importance in automative analytics. Okay, so let me just show you the importance. Okay, so what is the importance of multiple layer perceptron in this thing, automative analytics? A multiple layer perceptron is a fully connected class of feed forward artificial neural network. We know this. Okay, so it is a fully connected class of feed forward artificial neural network, like so ANN. Okay, neural networks are also being heavily utilized in the development of autonomous vehicles, which depend on analytic with predictive capabilities for success and safety. Okay, so neural networks are also being heavily utilized in the development of autonomous vehicles, which depend on analytic predictive capabilities for success and safety. And you can see deep neural networks are key in autonomous vehicles. Okay, they collect the input data from sensors, they process, then produce the correct behavior for the vehicle. Okay, so these are the important aspects in automatic analytics using MLP, guys. The multiple layer perceptron. Okay, so guys, this was all about MLP. So I have given introduction and importance in the automative analytics. So in tomorrow's session, we'll be seeing how we are gonna implement this MLP. Okay, how we are gonna implement this MLP, automative analytics, and we'll be seeing how this data will be useful. Okay, We'll be seeing how this automative analytics. So guys, before going to that, let me explain about conclusion too. So I'll get an idea what we are going to work on. So if you want to see a conclusion, so the intelligent devices seem to provide a more proactive intelligent solution for automation industry. So guys, it's going to give a more intelligent solutions for this automotive industry. So what it's going to work on. So companies like Helio Technologies are on similar paths to create deep learning devices. Okay, just as human drivers would. So they're going to still work in getting these solutions by processing the power size, but certainly it's going to appear artificial intelligence, which going to provide the most human-like solution behind the wheel. Okay. So these intelligent devices, okay, are more proactive and which are the intelligent things. Okay, companies like Helio Technologies, okay, that will process sensory data just as human drivers would. Okay, and they still is gonna work. Okay, doing the solutions what we are gonna get. They're gonna apply certainly artificial intelligence. Okay, so we have seen the conclusion. We have seen the importance. Okay, importance of MLP in automotive analytics. Okay, so guys, in tomorrow's session, we'll be seeing how this MLP will be useful. How this MLP will be useful in this automotive analytics. Okay, so thank you for attending today's session, guys. So tomorrow we'll be going with NLP. So make sure you attend my session. So in case if you have missed any session, so you can always watch the recorded videos. So thank you for attending the session.